Hey, welcome to The Explainer. Now, we've all gotten used to the idea of electric cars. You know, the ones you plug into a wall. But what if I told you there's a totally different kind of electric car? One that you fill up at a pump, just like we do today.
I mean, just think about that for a second. The speed of a gas station, the kind of range you get from a regular car, but the only thing coming out the back is water. It sounds a little bit like science fiction, right? Well, as we're about to find out, the tech is very, very real.
So a car that runs on water? Well, not quite. But that question gets right to the point. We all know gasoline cars create pollution, and battery electric cars, they're fantastic. But let's be honest, the long charging times and that little voice in your head called range anxiety are still a thing for a lot of people. And it's right in that gap that this other technology is starting to make a whole lot of sense.
The answer to that big what-if question is the hydrogen fuel cell vehicle, or HFCV for short. And yes, it's an electric car, but it's got a pretty revolutionary twist on how it gets its power. Okay, so how on earth does a car make its own electricity using hydrogen? The first thing you need to know is it's not burning anything like gasoline. This is a clean, quiet, and honestly, a surprisingly simple chemical process. The first thing to get your head around is that an HFCV is an electric vehicle. It's got an electric motor, it drives like an EV, it's quiet like an EV. The huge difference is where the juice comes from. Instead of carrying around a giant, heavy battery, it has its own little power plant on board, a fuel cell.
And the process itself is actually pretty cool. Inside that fuel cell, you've got hydrogen from the tank being fed across this special membrane. Now, this membrane does something really clever. It strips the electrons off the hydrogen atoms. Those electrons, that's your electricity. They go off to power the motor that turns the wheels. And the leftovers, the hydrogen protons, they just grab some oxygen from the air outside and poof, they become H2O, plain old water. That's it. No bangs, no fire, just chemistry making your car go.
So knowing how it works is one thing, but the why, that's what makes this technology so compelling. Let's dig into the big advantages that have companies and even governments pouring billions of dollars into this. First up, refueling. And this is a big one. You pull up to a pump, you connect a nozzle, and in about 3 to 5 minutes, you're full. It's the exact same experience as a gas station. No more planning your afternoon around a charging port.
And what about range? With a full tank of hydrogen, you're looking at around 500 kilometers, some models even more. That's easily enough for a long road trip, which really helps put that whole range anxiety issue to bed.
And this brings us right back to where we started. The number of harmful things coming out of the tailpipe, a big fat zero. Nothing. The only thing it emits is a tiny bit of water vapor. It's a really powerful picture of what our city air could be like. You know, it's not just clean, it's also incredibly efficient. A fuel cell turns about 65% of the energy stored in the hydrogen into motion. A normal gasoline engine, it's lucky if it hits 35%. Most of the energy in gasoline is just wasted as heat. So HFCVs are just way better at turning fuel into actual movement.
Okay, so I know what you're thinking. If these cars are so great, fast to fill up, long range, zero emissions, why isn't everybody driving one? Well, like with any new technology, there are a few pretty big bumps in the road.
And this quote sums up the biggest hurdle perfectly. It's the classic chicken and egg situation. Why would car companies build millions of hydrogen cars if you can't fuel them up anywhere? And why would gas companies spend a fortune building stations if there are no cars to use them? It's a huge coordination problem, and it's really slowed things down. Then there's the price tag. Right now, a hydrogen car costs a lot more than a similar gas-powered one. A big reason for that is that they're not making very many of them yet, and the fuel cells themselves use expensive materials, like platinum. Now, those costs are coming down, but for now, it's a major roadblock for the average person.
And this might be the most important but in the whole conversation. The car itself is totally clean, but you have to ask, where are we getting the hydrogen fuel from? And today, a whopping 95% of it is made from natural gas, in a process that, you guessed it, releases CO2. This is what's known as gray hydrogen. So even though the tailpipe emissions are zero, the well-to-wheel emissions are a whole other story.
So, you know, when you put it all together, you really see the size of the challenge. The cars cost a lot, there aren't enough fueling stations, And most of the hydrogen we make today isn't actually green. It's a puzzle with a lot of pieces, and they all have to be solved together for this to really take off. So, with all these pros and cons on the table, what's the verdict? Is hydrogen a dead end, or is it a key piece of our energy future? Well, the answer might surprise you, because this technology is already having a huge impact in a place you'd probably never expect. Get this, there are already more than 25,000 hydrogen-powered forklifts zipping around warehouses for companies like Amazon and Walmart. You've probably been near one and had no idea. Why? Because for them, it's a no-brainer. They can refuel in just a few minutes and run an entire shift, which makes them way more productive than a battery-powered forklift that needs to be parked and charged for hours.
And that's where the future of hydrogen really starts to come into focus, at least for now, in heavy-duty stuff. Think about long-haul trucks, city buses, even trains and ships. Trying to power those with a massive, multi-ton battery that takes all night to charge, it just doesn't work. But a hydrogen system, with its lightweight and super fast refueling, it's a perfect fit.
And ultimately, that's what this all seems to be pointing to. It's probably not going to be a war between batteries and hydrogen. The future isn't about finding one silver bullet that wins. It's about building a whole toolbox of clean solutions. We'll likely have battery electric cars for our daily drives and powerful hydrogen fuel cells for the really heavy lifting, moving our goods and ourselves across huge distances. So the real question isn't which one is better. It's how do we build a future that uses the right tool for the right job? Thanks for joining this explainer.